And it's funny because it always on the resume kind of looks like what's going on here. But I'll tell you, so much of being able to get into this and get started, the things that you learn along the way, great tech without an execution plan, without the right team, without capital is just going to sit on a shelf somewhere. So my journey is definitely not traditional, but I think it was very helpful in getting us to where we are.
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Ryan McDevitt, CEO and co-founder of Benchmark Space Systems, a full life cycle in-space mobility provider. It's a mouthful. Ryan, thanks for chatting with me today.
Yeah, thanks so much for the invitation. Excited to be here.
Oh, that's great. Well, first of all, can you tell me a little bit about your background and how you got into co-founding Benchmark Space Systems? I mean, co-founding a space company, pretty cool.
It's been a great adventure, and it brings together two things that I love, which is engineering and technology and the business side of it. So the quick background is back in 2003, I was doing my undergrad, got to work on some pretty cool micro propulsion technology, which at the time was total sci-fi stuff. It's the very early days of CubeSat. Barely anyone had heard of it. No one was doing, any of that kind of stuff, and got into it and loved it. Thought it was really interesting, but there was no business case for it. So afterwards, I did what so many of us do, and I went and worked, and I was doing work at Pratt and Whitney, working on jet engines, and that was fun, but it wasn't what I wanted to do ultimately. Took a educational detour into the business world, bought a business with my wife. We ran that for years, so kind of got into that part of it. But that itch and that kind of thought about, hey, what can propulsion do for satellites was always kind of in the back of my mind. 2009, I got an opportunity to get back into it. And it's kind of been away from there. So graduating with my PhD in 2014, we had researched some technology, and I had a way to patent it, take it forward. And that was the genesis of Benchmark Space Systems.
Oh, very cool. And what a journey, go into business with your wife and then jump back out into space. So
yeah, and it's funny because it always on the resume kind of looks like what's going on here. But I'll tell you, so much of being able to get into this and get started, the things that you learn along the way, great tech without an execution plan, without the right team, without capital is just going to sit on a shelf somewhere. So my journey is definitely not traditional, but I think it was very helpful in getting us to where we are.
Yeah, that entrepreneurial knowledge base, it's not something you can just inherit. You have to live it or have someone that's lived it with you for sure.
Right.
Give us an overview then of Benchmark Space System. What is its core mission, and what are you providing as your products and services?
Yeah, absolutely. So when we got into this, I mentioned we had kind of one technology. It was propulsion, chemical propulsion for small satellites. And that was the idea. And I'll tell you, if you were to look at my very first kind of pitch decks or business plan, it was really a product focused business. We were going to build this hardware. We were going to sell, one size fits all to as many customers as possible, and kind of go from there. But, as they say, that plan didn't really survive first contact, because when we got out into the market, what we identified is that the customers that we were working with, especially on the commercial side, many of them had never worked with propulsion before and weren't really familiar with what it can do and how it can enable their mission. And so we really had to get involved in the very early stages of spacecraft design, mission planning, helping them to think through their actual maneuvers and concept of operations, what their end of life was going to look like once they had propulsion on board. We had to help them think about ground fueling and ground support and all these different pieces. And so along the way, we've evolved how we think of ourselves, how we present ourselves, and how we operate, really from being a hardware propulsion company to what we call an in-space mobility provider, right? We're helping to solve that gap. If a customer has a satellite and it's at point A and they want it to be at point B, Benchmark can help them solve every step of that process. We do that through our hardware products, like our Halcyon Avant chemical propulsion systems. We do that through our software products, like our Smart Aim family of mission planning and operational maneuver support. And we do that through our services like ground fueling, mission design, and spacecraft operations. So when you tie all of those together, when you put all of those pieces together, that's really how you get to this full service, complete solution set provider that Benchmark aims to be.
That now makes sense on the title of why I read it that way. No, that's very cool. I want to come back to getting from point A to point B, but why is what you're doing so, innovative, and What is the differentiator from a standard propulsion system that's been in existence for years or that has been around just for a little while?
Yeah, so we really focus on three key areas of making our customers' lives easier. So one is our choice of using non-toxic propellants, which is important because it makes that ground fueling easier, it makes operations easier, and it makes the total cost of ownership, the kind of full end-to-end cost, lower. So you can imagine that it means we can put our propulsion products into the hands of more customers because they can afford to buy it. The second piece is around that smart propulsion. So we put it under this trademark name, Smart Aim, but really it's this idea of tying together and making the propulsion system able to ingest information from both the spacecraft and the environment and make real-time improvements to the propulsion maneuver so that you're more fuel efficient, you are safer, you're able to handle changing conditions. So that's something that's innovative that we're tying together with the non-toxic propulsion system. And then the third piece is really that full stack support. So it's very common for people to buy propulsion piecemeal, right? They'll buy thrusters from this company and tanks from that company and valves from that company. And the spacecraft integrator is putting all of those together. And they may work well together, or they might have some little quirks. And so by tying that all together, when someone comes to benchmark, because we have this full solution set, chemical propulsion, electric propulsion, guidance, navigation, control software, they're able to get the best of all of those pieces that are tightly integrated and, pulling the best out of each of the components.
Are you finding because you offer that as a full package, it's more the niche type satellite companies are coming to you, or are also the big primes and folks?
Yeah, so I would say our sweet spot today with our primary product set is what we consider like the near vertically integrated spacecraft manufacturer. So they might be building the full bus, they're sourcing components from other pieces. They might even be building most of the components in-house. But when you start to look at propulsion, it's such a different beast, right? So you've got, depending if it's chemical, you've got the chemistry involved, you've got hazard, you've got fire, you've got all these different pieces. They don't necessarily want to have that under their roof. If you're on the electric propulsion side, you need specialized equipment, specialized vacuum chambers, all these different pieces. So we're able to offload that burden from that near vertically integrated manufacturer, say we can be your partner and we can provide, and you might do 5 different kinds of missions. This one's going to the moon, this one's in LEO, right? And we can support all of those different things. So to specifically answer your question, our primary customer base right now looks like a new space manufacturer. So it's a non-traditional, non-prime that's looking for a long-term partner as they are expanding their feature set. With that said, we are, as we continue to develop or build flight heritage, develop new products, and especially as we are more aggressively moving into the defense market, we're seeing a lot of traction with those prime contractors because they're recognizing the value of what we do.
All right, so back to the propulsion. What non-toxic chemical do you use?
So normally the most common propellant for especially chemical propulsion in the US is hydrazine. Hydrazine's been around since the 60s. Many people refer to it as it's a propellant chemist's platonic ideal of a propellant in the sense that it is great at all the things that propellant chemists care about, but no one else likes it. It's hazardous. It's toxic. If you spill it on the ground, the cleanup is a mess. If you're loading it, it's expensive because you have to have a lot of oversight, documentation, DOT, all these things, right? So hydrazine is the industry standard and will be for the foreseeable future because of that momentum, right? But what we see is a different way to do this. And I will say that we are one of several companies worldwide who are really making a big push into non-toxic propellants. And our specific chemistry is hydrogen peroxide, which is
It's used when you cut your arm.
Yeah, that's right. Exactly. So if you're used to 3% peroxide that you might have in your bathroom and it cleans up the cut, we're taking that a little bit higher test. So 90% hydrogen peroxide, which has a long space history, but fell out of favor when hydrazine came into play. And also there was a lot of bad process in the early days of using hydrogen peroxide. If you're careless with it, it can cause issues. We're really educated on how to do this. There are new processes, both that have been developed at other places and that Benchmark has developed. And with proper handling and proper care, hydrogen peroxide is a great propellant for a lot of these new space missions. So we're really excited to be championing that and educating. I mean, we do a lot of outreach. We go to conferences. We write papers on this because we think that with the proper education, it's going to be a great propellant for years to come.
Is the performance significantly different? Like if I took the same volume canister of the same, are you going to get more out of one or the other significantly, or is it?
Typically hydrogen peroxide and hydrazine. One thing that's interesting about both of them, they can be used by themselves as propellants. In that scenario, called a monopropellant, so one propellant. When you do that, hydrazine's more effective, so it's got an advantage there. However, one of the things that hydrogen peroxide does, I mean, it's right in the name, it produces a lot of oxygen when you are decomposing it, and you can burn that oxygen with fuel. And so when you burn hydrogen peroxide with fuel, and you can do a similar thing with hydrazine, you can burn it with fuel. Now hydrogen peroxide actually has an advantage. It has an impulse density. So in your, the way you said it, it's exactly right. For a unit volume, how much performance can I get out of it? Hydrogen peroxide plus fuel has an impulse density advantage over hydrogen. So not only are we, lower cost, safer to use, so shorter timelines, all of that benefit, it is performance competitive, and that actually has advantages in key areas to hydrazine, which is why we're such believers and, really going out and proselytizing it.
Fantastic. So in this, in your propulsion systems, can you talk about the size of, it's not the rocket sitting at the bottom of Elon Musk monster, rockets. These are small.
That's right. Yeah, exactly. And so they come with their own challenges, very different, right? So we're talking all the way down to propulsion systems that fit on a spacecraft the size of a loaf of bread. So now you're talking about thrusters that are, this size, up through, we've built propulsion systems that carried a satellite the size of a refrigerator. So now you're talking about a propulsion system, maybe the size of a fairly large coffee table, and, thrusters this size. We are actually under contract with the U.S. Air Force to build even our next generation, which is going to be, off the screen big, right? So we're, kind of working our way up. I would say the key differentiator between what probably a lot of listeners, viewers have seen before with like a SpaceX rocket or something like that. Those are big. They have turbo pumps on board that are keeping everything moving. They're usually using cryogenic propellant, so like liquid oxygen, right? So you're always seeing that steam blowing off as you're about to have a launch. Everything that we're doing is pressure fed, much smaller, and it's all liquid. So liquid chemical engines. So
that was the propulsion.
Yeah.
Now, if we get into the next piece of your moving from A to B.
Yeah.
First of all, share with listeners, why would someone want to move a satellite? You got it in orbit. It's sitting there.
Yeah.
It's going around the Earth or whatever it happens to be doing, but it's in orbit.
So historically, like once upon a time, you didn't need to really move them, right? The big things that you might want to move them for would be tasking. So if you've got a satellite that's up there and it's taking pictures of something interesting, whether that's a civilian, commercial, or defense, you can think of all sorts of reasons why you might be doing that. You might want to move it, right? You've got that asset up there. It's expensive. It's not easy to launch them. So you're going to move that. So that's the really straightforward one. The new thing that probably a lot of people are becoming more familiar with is it's getting really crowded up there, especially in orbits that are interesting. And so now we're doing a lot of maneuvering to avoid hazards. So collision avoidance is one of the big things there. Usually we talk about that in terms of avoiding kind of other satellites that might be moving more slowly or, in a crossing orbit. You can extend that out to thinking about, what if someone were actually trying to take down a satellite? How would you avoid that, right? Evasive maneuvers. So there's some thinking going on about that part of it. And then the other new one, we used to just put stuff up in space and let it stay there. We would put it with the rules in place. Maybe it comes down within 25 years. Not even everyone even stuck to that rule, but that was kind of the idea. That's not a good enough rule anymore. So the FCC has changed that. It's 5 years. So now your point A to point B might be from space, getting it back down to Earth, whether that's going to burn up on reentry or you're going to aim and bring it down to a specific location. So I just give you 3 different reasons you might want to move it around: tasking, collision avoidance, or deorbit. All of them can be done with the same propulsion system, same characteristics.
And imagine your customers primed on defensive, evasive maneuvers if certain satellites are being attacked in the next, a potential conflict.
Yeah, well, and it's an interesting thing because there have been a lot of launches over the last 5-6 years where other countries are demonstrating and practicing capability of going and inspecting satellites going and capturing satellites, right? So a rendezvous maneuver where they go and capture. Now, right now they're doing it with their own. They're just demonstrating the capability, but it doesn't take a large, kind of leap of faith to understand like, okay, this is where this is going. These capabilities are going to exist. We need to have counter capabilities. And that's where you say, yeah, evasive maneuvers. This is beyond the hypothetical. It's not Star Wars stuff, right? People sometimes think it's not dogfighting in space. That's not really what we're talking about, but being able to have some control of your spacecraft so you're not just a sitting duck, it's got to happen. And we're seeing a lot of demand for that.
So as mobility is increasing over time, you only have so much fuel. You're a satellite that's up there for years, maybe even a lower orbit where it's being, the tendency is to fall and you got to continue to. How do you stay up there? Or is that just you run out of time and you come back down to Earth?
Yeah, so current state of the art, unfortunately, is pre-planned maneuvers where you know exactly how much propellant that you have. You go up, and when you run out of fuel, you need to plan it so that you come out of orbit accordingly. As you can imagine, Department of Defense, U.S. Space Force, that is not an acceptable long-term plan for them. So we have seen a lot of activity going into on-orbit refueling, which is a really exciting field. And for someone like me, who's, A, loves the stuff for the science of it, but B, the business case, being able to build something out, we've had the good fortune of working with Daniel Faber, Orbit Fab. We helped them with their kind of first mission, demonstrating their Rafty product, which is an on-orbit refueling servicing port. So we've been thinking about and working with them on what does the future of this look like. And we're, big fans. We're super excited about what that looks like. This idea of have a satellite that can go to a gas station in space, connect, refuel, and keep it operational even longer. That's the future. And I can't tell you if that future is next year or 10 years from now, because there's still a lot of moving parts. But I can tell you the march of time is inexorably toward that endpoint.
That was so cool. And yeah, we had Daniel on the podcast as well with Orbit Fab.
Awesome.
Shared a lot of his story. So it's very cool. Those the two stories intersect.
Oh, great. I'm glad to hear it.
So why you mentioned also the software component. Why is, I'm just thinking if you're at a certain altitude, do you really need software to evaluate what all is different and then it changes how you use the propulsion? Is that not inherently obvious?
So I would say most common current state of the art for many spacecraft, it was really designed in the world where, you either launched a single satellite or maybe you were launching a small constellation. You might have 5 to 10 satellites that were part of your constellation. You can do that all manually, right? So you can track it from the ground. You can send it updates. Oh, we're a little bit lower than we want to be. We're going to do a maneuver. We're going to raise the altitude by, a few kilometers, right? That can all be very manual and it can be very slow. Modern operation looks like hundreds or even thousands of satellites moving at very high speeds, potentially very close to each other. You have to figure out some way to automate that. And there's different levels of automation. So there's the ground automation where it's tracking everything, sending data, and letting the user know so that they can make decisions about it. What we're looking at is the onboard automation or the edge automation, right? So how can we make it so the propulsion system can react to changes in the spacecraft? If a hazard is coming up, how do we make sure that we're not going to crash into it, right? So we've announced partnerships with space situational awareness companies like Payhan Space, where we can actually take data from their stream. So they're up there, they're tracking all of the satellites that are up there, and we're able to take that information, feed it into our propulsion system, make a recommendation to the satellite. So we're not taking control, but we're making a recommendation to the satellite. Hey, you might want to make a maneuver. You are close to something dangerous. The satellite can decide to act on that, and we can do a short, fuel efficient maneuver, get out of the way, and then return to operation, minimizing downtime. If you have that asset up there, right, it's really expensive to build and launch these things. You don't want it out of service for days or weeks because you had to maybe avoid something. If you're going to do an avoidance maneuver, you want it to be fast and you want it back into operation as quickly as possible. So by putting those smarts onto the satellite, into the propulsion system, you can cut the whole back and forth data link with the ground out of it and speed that process up.
That makes sense. Absolutely. So as you've been on this journey, what are I'd say the most significant challenge that you face that you've been able to overcome while developing this suite of systems to, full life cycle propulsion?
The biggest challenge that we have faced, I mean, they kind of coincided, but the market has changed a lot since we first got into this. So we got into this in 2017. And I would say the first 3 years of our effort, we were learning, we were talking to customers. But, I mentioned, the big push at the beginning was smaller, very small satellites, CubeSats, right? So we always use the loaf of bread as the analogy for people to picture. I mean, that's a very small spacecraft. And there are very successful businesses that are operating around those spacecraft. Planet, Spire are two examples of companies that are doing very well for themselves, publicly traded companies that use those CubeSats as the backbone of their infrastructure. And so we thought when we got into this, hey, we're going to build a product that's aimed at that market and really go after it. And what happened is the market shifted. People identified, hey, we're kind of reaching the limits of what we can accomplish with CubeSats. We want bigger satellites. We need more power. We need bigger solar panels. We need bigger antennas. And in 2020, we kind of reached a point where we had customers, as in we had people that were engaged with us or even people under contract, and our products were no longer responsive. And not just our product, our technology. The thing that I had done my research on, the thing that we had taken forward was no longer the right solution. And, that's a really existential challenge, right? You look at it and you go, I don't know what to do with this. And as a first time, in this CEO founder had taken private investment. So I'm like, I'm going to have to go back to my investors and say, hey, it was a bad idea and we shut down. And sometimes that happens and that's part of the process. For us, we ended up finding a company out in California that we had met through some Air Force contacts, had similar ideas, similar technologies, but had a product set that was better aimed at where the market was going. We were able to bring that team on board, integrate them into what we do, and off the back of that acquisition and the subsequent technology integration, we signed our first commercial contract, and it's kind of been away we go from there. But that was it was a very hairy moment, and it was all happening right at the beginning of COVID. And so we were, facing, do we shut down? Are people going to have to work from home? We were in the middle of the integration. So I'm going to say that we had, what was our biggest challenge? It was working through that, keeping the investors excited, keeping our customers calm, and integrating that new team all during COVID. There are a lot of scenarios in which the company doesn't exist today if that didn't come together the way that it did. And I will say, it can look like, I did something amazing. My team handled that so well, brought everything together, solved those technical challenges, worked through supply chain disruptions and all the, that early confusion and fear and trying to get everything settled. So I'm just really thankful to my investors, my team, and the customers to help us get through that part of it.
I just pictured, that type of pivot would be hard, never mind all the other pieces. Yeah. Who did you rely on for like that, I'd say mentorship, guidance that could walk you through this with, no judge, trying to just work through the best thing and not worried about maybe their own capital, or maybe they just were able to set that aside. Like who did you rely on?
I had kind of a business advisor who was one of our earliest investors. I'll tell you a quick story. The first time I met him, I had just graduated from UVM, University of Vermont, which is where I did my PhD. I was thinking about this business, and he did pitch coaching. So I went and met this guy, and I did a pitch for him, right? My 5-minute, this is what I think, this company could be. And no joke, he said, that was the worst pitch I've ever heard. You talk like an academic. Go home. If you're still serious about this, come back tomorrow with a better pitch. And if you do a good job, I will take you on as a mentee. And I'm here today, so hopefully I did a better enough job. But that's the kind of the person who he is, that candor, that support, the experience to be able to say, hey. And when I came to him, he was my first call when I said, I don't think this is working. I don't think our products are going to get where we need to go. And we're close. There's a lot of good stuff here, but we're just not quite there. And he kind of led that. The other is we had on our board of advisors a former astronaut who, had connections at Boeing and NASA, and he was really able to help me understand, where the market was going and give me some guidance there. So between that kind of technical business side of it and then the entrepreneurship startup side of it, the two of them really were my saving grace there.
Yeah, I could only imagine without that, you'd be just feeling like you're on an island.
Yeah.
Probably felt like that anyways.
Yeah, absolutely. I mean, no, that's right. I mean, looking around and you've got a team and, I had people that had moved here. All these people, their hopes and dreams were tied up in what we were doing. And so without some path forward, some potential, it would be a difficult conversation. And it happens all the time. And, that's kind of what I signed up for. So I'm not, it would have been what it would have been. But I'm, again, thankful that we're here.
Where do you see, space technology evolving in defense, strategies over the next decade, let's say?
I think the biggest things that I see there, I kind of hit on one, but I'll reiterate is, we're seeing a lot of other countries, adversarial countries that are demonstrating maneuver capabilities that are at the upper end of what we typically think of as, modern space maneuvering. So that looks like those rendezvous maneuvers, very close following distances, very quick maneuvering. So that's high thrust. They're going from point A to point B very quickly, and then kind of dropping into this other mode where they might be moving more efficiently. That's really going to put a lot of pressure on the US and our allies to make sure that we have comparable capability. So there's a lot of movement there. I would say the other interesting side of that is as more stuff goes up into space, so more commercial hardware along with defense hardware, one of the things that's interesting and maybe not unprecedented, but it's definitely specific to space is it's all the same space, right? And so the commercial and the civilian and the military are all operating in essentially the same locations. And it's going to become increasingly difficult to differentiate between them, especially when we talk about people that we're not allies with or we're not information sharing with. So additional inspection capabilities, which often there's stuff we can do from the ground, but at some point you just have to have eyes on, and that looks like spacecraft that are more mobile and able to go and do inspections. Maybe the last piece I'll add is the Space Force has made it a stated goal that they think helping U.S. Interests in all the way out to the moon, so cislunar space, is part of their mandate. And so right now that basically looks like a few commercial missions every couple of years and then some NASA stuff. But as activity there picks up, that's really going to drive new capabilities and new demands onto the Space Force and their mobility needs, right? Being able to move from low Earth orbit to geosynchronous orbit up to cislunar space and back. That's a very fuel intensive set of maneuvers. So without increases in efficiency and increases in refuelability, that's not an actual thing that we can do. So that's what's really going to drive, I think, a lot of the investment and the energy over the next decade.
Okay, so I'm going to give you a couple questions. Just give me just like 1 or 2 sentence response. I don't have to go too deep, but your favorite collaboration or partnership that you've had with Benchmark Space?
Oh, so this is an easy one. I already spoiled it, but it was with Orbit Fab. Okay. And the reason was because A, they were doing something really exciting and interesting. And B, we were both at the perfect time in our company's development to learn a ton from each other and be able to teach each other a bunch. So that was fun.
Who would you like to partnership with next?
I'll say the type of company I want to work with is we're really excited about hybrid propulsion, chemical and electric on the same spacecraft bus. And we have some exciting partnerships that we're going to be announcing here later this summer. So, hopefully your audience stays tuned, but we're going to be doing some really cool stuff with the kind of next generation of propulsion.
What's the most challenging aspect of working with the government?
Just the time, it requires, persistence and patience and managing expectations for our investors, our board of directors, and our employees and other stakeholders, because our commercial stuff moves so fast and our government stuff moves so much slower. And those two timelines can be really challenging to manage.
How about the best part of working with the government?
Consistent. So they do what they say, at least in our experience. And once we are working with them, they follow through, they deliver on what they say they're going to. The commercial market, is kind of at the whims of private investment and all these different cycles. And the government is there, slow and steady, but always a backbone for us.
What advice would you give to aspiring entrepreneurs that want to get into the space industry?
I think it really just comes down to consistency and patience. I mean, those two are things I said how I think about the government, that's how you have to be as well. I think there's often this desire to shortcut and go straight from, I met someone this time and I'm going to be under a big contract tomorrow. And really it's working your way through the process, getting them familiar with you, making sure that you have all of your compliance stuff lined up, right? Like that's a whole special thing that people don't think about enough. And so making sure you've got all of that lined up, those are the things that stand out to me.
Well, Ryan, this has been awesome. Really enjoyed it. Any final thoughts or messages you'd like to share with our listeners?
I appreciate the time. Thank you so much. Check out our website, our LinkedIn page. As I mentioned, we have a string of announcements coming out over the next little bit that I think is really going to help set the stage for, where mobility is going. It's obviously a topic I'm passionate about, but I think everyone can find this fun and exciting. And satellites moving around in space, what could be more fun, right?
Sounds so exciting. That's so cool. Well, I've really enjoyed this, Ryan. Thank you for your time, and let's stay in touch.
Awesome. Thanks so much.
All right. Thank you.